We are now going to talk about the cardiac conduction system. We're going to find out how electrical current is generated by the cells of the heart, and once it's generated, how it is transmitted to all parts of the heart cells. This is what's called the cardiac conduction system. So let's begin. Similar to highways, when we travel through a highway, the travel is usually fast and smooth, and basically the transfer or the travel of electricity from one area of the heart relies on a highway system, and this highway system is what is known as the cardiac conduction system. So let's talk about where this current is generated first of all and how it spreads about. So located on the upper right atrium is going to be a specialized group of cells, and this specialized group of cells are what we call the SA node or the sinoatrial node. The SA node has a property of being able to generate electrical impulses at a very fast rate, at around 60 to 100 beats per minute. In comparison, there is another area right over here between the junction of the atria and the ventricles called the AV node, which actually has a firing potential of 40 to 60 beats per minute. And lastly, there are cells right in the ventricles as well that are able to generate electrical impulses, and they are able to do so at a rate of 20 to 40. So let's trace the formation or the generation of an electrical current and how it spreads throughout the heart. So let's say that an impulse is going to start from the sinus node. It's going to spread through the atria to the right atrium by way of what we call the internodal tracts. And this particular impulse also travels into the left side of the heart by way of another track or highway. And this highway or this pathway is known as the Bachmann's bundle. Now, the transmission of electrical impulses through the atria on the right side as well as on the left side will result in stimulation of muscle cells, which in turn will depolarize them and eventually cause contraction. So once this electrical energy has now traversed the entire atrium, the electrical current will now arrive at an area at the junction of the atria and the ventricles. And this particular area that I'm shading at right now is what is known as the AV node, also known as the AV junction. And this AV node has a particular characteristic in the sense that it is able to slow down the velocity or the movement of electrical current through it. It delays electrical impulses at a rate of around 0.10 seconds. And this is very, very important concept. Why is there an AV delay of this movement of electrical current once it arrives in the AV node? Well, God created this delay in order to ensure that atrial contraction finishes before ventricular contraction. As you could see, the atria and the ventricles do not contract at the same time. God created two pumps for our heart so that while the atria is contracting, the ventricles are going to be relaxed in order to receive the volume that the atria is introducing through. So this delay of electrical impulse in the AV node ensures, therefore, that there's going to be complete atrial emptying before ventricular contraction occurs. Alright, so once this electrical current arrives in the AV node, it now travels through the ventricles. And it first travels through a common highway right here next to the septum, and this is what is known as the bundle of His. The bundle of His splits into the one going into the right, called the right bundle, and one going into the left, which is called the left bundle. And actually the one going into the left, in as much as the musculature of the left side of the heart is bigger than the right, actually has another tributary or another branch also known as a fascicle. And this fascicle goes around the posterior portion of the heart or the back portion of the heart. And this is what is known as the posterior fascicle. The one that goes down over here is going to be your anterior fascicle. So the electrical movement now, again, from the AV node goes into the bundle of His. From the bundle of His, it splits into the right and also into the left bundle branches. Now, once this electrical energy is going to arrive at the ventricles, it must penetrate the thickness of the ventricles. So these bundle branches rely on root-like structures, and these root-like structures are going to penetrate, or so to speak, deliver the electrical energy through the thickness of the ventricles. And these particular branches of the bundle branches are called the Purkinje fibers. The Purkinje fibers are the termination point of the electrical energy that is delivered into the heart. And so once there is going to be the arrival of this electrical energy into the ventricles, it causes the stimulation of ventricular cells, muscle cells, to depolarize and eventually contract. So this is the way in which electricity is generated by the heart and how it spreads throughout the rest of the heart muscle. So in summary, it begins with the SA node. So what is the function of the SA node? Again, the SA node is the one that generates and sets the pace of the heart rhythm, and therefore it is known as the pacemaker of the heart. It is located in the upper right atrium near the inlet of the superior vena cava. It has the highest level of automaticity. As demonstrated over here, it has a speed of around 60 to 100 compared to the AV node, which also is able to generate electrical energy, but at a slower rate of 40 to 60. The ventricles also have the ability to generate electrical impulses, but they do so slower than or compared to the rest. It has a rate of approximately 30 to 40, although some authors would say it's around 20 to 40. Now, from the generation of an electrical impulse from the right atrium of the SA node in the right atrium, it spreads to the left side by way of Bachmann's bundle and onto the right atrium by way of internodal tracts. Remember that in our discussion of cardiac or coronary circulation, we said that the SA node is supplied by the right coronary artery in majority of cases, and therefore any pathology on the right coronary artery can interrupt or can interfere with the proper functioning of the SA node. Now, the other system or the other part of the cardiac conduction system is the AV node, and we had said that the function of the AV node is going to slow down conduction to allow for the atria to contract before the ventricles. The AV node is located near the tricuspid valve, and it is going to delay the electrical impulses in order again for ventricular filling to occur properly. And of course, inasmuch as it has the ability to generate electrical impulses on its own, although slower than the sinus node, it can serve as a backup pacemaker if the SA node ever fails. And lastly, we look at the distribution or the transmission of electrical impulses into the ventricles, beginning with the bundle of His. And from the bundle of His, there's going to be a split of the movement of electrical energy, one going into the right through a highway or to a pathway called the right bundle branch, and of course going into the left through a pathway called the left bundle branch. Inasmuch as the left ventricle is bigger in mass compared to the right ventricle, the left bundle branch has another tributary, and this is what we call a fascicle. The left posterior fascicle is going to serve the posterior part of the left ventricle, and the left anterior fascicle is the one that's going to be responsible for distributing electrical energy into the anterior portion. Now, the termination point of these electrical energy is going to be through Purkinje fibers. And the Purkinje fibers are those that extend from the AV bundle, and the function is to relay impulses to the ventricular cells. Because of the thickness of the ventricles, we need these tributaries in order to be able to distribute the electrical current to all myocardial cells of the ventricles. This concludes our discussion on the cardiac conduction system.